G'day, we're talking about first principles days, or the introduction to first principles. So when we start looking at differentiation, we come across something called the first principles, which is basically an introduction to gradients on curves. What we've got here on the board is an equation which is y equals x squared. And what I'm going to do is I'm going to explain to you how the first principle rule comes about. So if we have a look at this graph on the board here, let's just take a spot on here. And what I'm also going to be calling this here, instead of calling it y equals, I'm going to call it the function is equal to x squared. So if I take this spot on this curve at this particular point, we might call this here x. And then we might say, well, let's take another spot on this curve and let's call this part up here, that second spot. I don't know anything about that spot except that it's some distance away from x. So what we call here is we'll call this x plus h. So this point here is x, and this point here is the x plus h. So we can see that in the middle between these two, we have a distance of h units. So we found out what our x values are in terms of f of x. If I want to find what the y values are, well then I need to work out what the function of these values are. So in this first one here, these coordinates here would be x and f of x, because if I wanted to find the y value of x, I replace that y in the function, that value in the x in that function to give me that y value. And the same thing would happen here. If this here is x plus h, then the y equivalent will be x plus h, or the function of x plus h. And this gives us the idea of where we get our gradient from. We know that first principles is the same thing as finding the gradient on a curve. So we know the formula for a gradient is y2 minus y1 over x2 minus x1. So this here was a straight line. I could use that straight line and work out the gradient of that line. In calculus, in which we're looking at right the first principles, we have a different notation for this. And that notation has two different values, two different ways we write it generally. The first one is dy dx, or the derivative of f of x. So if we had a calculation that started with y is equal to, the gradient to this here would be dy dx is equal to. Or if we had a function that's f of x, the gradient of this here would be the f dash of x. So what we've looked at here now is we've looked at the fact that we've established that we're finding the gradient on this curve. So let's come back and have a look at how this relates to what we've just looked at. So m y1, y2 minus y1 over x2 minus x1. Well, if I'm going to do dy dx here, well, my y2 would be this one here. I'd have f of x, or f of x plus h, minus f of x, the function of that. And over the top, I'd have my x plus h minus x. So this here is the same, it's going to be doing the same thing as I did with the straight line gradient. I found the gradient at a particular point on that curve, but I can simplify this down. I can simplify this down to being dy dx is equal to the function of x plus h minus x plus h all over h. So how does this work? Well, if I was looking at this graph here, I'm going to move something over and put a little space here for a second because we're going to be quickly talking about limits. We place something in here which is called a limit as h approaches 0. Now what that limit's telling us is we're saying we wanted to reduce the distance between these 2 points to the point where we can substitute 0 in there. So it's basically saying there's no distance between these 2 points at all. At that exact point, that's where we're going to have our gradient. So the way we do this is we write the limit as h approaches 0. And that's just basically bringing these two closer and closer and closer until they're basically on top of each other, and the distance of this h no longer exists because they are at the exact same point. So this is where the idea of first principles comes from. And we're going to be doing some examples on these in the next video, just so how you can see how it's used. And I'll see you then.